Welcome to 8.5 Systems of Linear Equations in 3 Variables. Now, you'll notice here we still have system of linear equations, but we have x, y's, and z's now. So, before we only had 2 variables and our solutions were ordered pairs. Now we have 3 variables and our solutions are ordered triples. Now, the elimination method is generally the method that works best here. And it's a lot like the stuff we were doing with 2 variables and 2 equations, except we're going to have to just do a couple repeated applications of it. So what we're going to do is take a look at this first one here. Now, if I look at this, it's good to take a couple seconds to look at this and find out what's going to be the easiest variable to eliminate. And we're going to have to do it a couple times. So if we just look at the x's here, we have an x, a 2x, and a negative x. X's look pretty good, like we could eliminate those with not too much trouble. The y's, we have a y, a negative y, and a 2y. Y's don't look bad either. The z's, a z, a 5z, and a 2z, those are probably the hardest one to get rid of, so just choose either the x's and y's and eliminate them. Now, the first thing we're going to do is to choose 2 of these, and I've numbered them over here. We have number 1, number 2, and number 3. We're going to choose 2 of these and eliminate one of the variables. I'm just going to choose x, so I'm going to choose the first and the third. So just rewriting those, we have x plus y plus z equals 2. And negative x plus 2y plus 2z equals 1. Now, if I add these together, the x's are eliminated. We get 3y plus 3z equals 3. So, what I'm going to do is I'm going to put this over to the side because I'm going to use that later. Because the whole idea is we want to reduce the 3 equations with 3 variables to 2 equations with the same variables. So we have a 3y plus 3z equals 3. Okay? So I've used the first and third to get an equation that has just y and z in it. Now I need to either use the first and second or the second and third, another pair of those, to eliminate the same variable. So I'm going to use the second and third to eliminate the x's. Okay, so in order to do that, I'm going to have to multiply this third row by 2. So I'm going to recopy the second row down. We have 2x minus y plus 5z equals negative 5. Let me do this. Okay, so I'm multiplying this whole thing by 2 to get rid of the 2x. So when I distribute this in, this is going to give us negative 2x, distribute this in, plus 4y, distribute this in, plus 4z, and then multiply it by here, equals 2. So the one thing I'm going to say is be very careful, be very conscientious about what you're doing, because if you make one little mistake here, it's going to ruin the whole thing, and it gets really bad really fast. So I'm eliminating the x's here, they go away. Negative y plus 4y is 3y, and then we have plus 9z, and then we have equals negative 3. So notice, we added 2 of these equations here together, and we got rid of the x's. So we need to take a different set of 2, eliminate the x's again. Now what we're doing is we put this equation over here, 3y plus 9z equals negative 3. So the idea is we've taken the system that has 3 variables and 3 equations and turned it into something that now just has 2 variables and 2 equations. Now we can solve this like we normally would to get our y and z values, and then to get our x value, we're going to plug it back into something over here. So now we're going to solve this system right here. So I'm just going to use the elimination method to get rid of the y's. So I'm going to multiply this top row by negative 1. Copy down here. So we have negative 3y minus 3z equals negative 3. So distribute it here, here, and there. Now I'm going to add these 2 together. The y's cancel. 6z equals negative 6. Divide by 6, and we get z equals negative 1. So, like I said, the solutions to these are going to be ordered triples. It's going to be some sort of x, y, z combination. We know that z equals negative 1, so we plug that in. So just like we normally would when we have 2 equations and 2 variables, we can use this value of z, plug it into one of these 2 equations right here to get our y. So I'm just going to plug it into this first one here. So we'll do that right here. So we have 3y plus 3 times negative 1, plugging our z value in, equals 3. So you have 3y minus 3 equals 3. Add 3, and I'm running out of room. Come down here, sorry about that. And we get 3y equals 6. Finally, divide by 3. And we get y equals 2. Okay. So, kind of recapping what we've done so far, we've taken two of these equations, eliminated the x. And then we had taken a different two and eliminated the x again. And we've taken both of these and put these over here to have this little system of equations with two variables and two equations. This we could use substitution, elimination, what we want, whatever we want, but this helps us, just like we normally would in the previous sections, find the y value and the z value. So once we have those y values and z values, the only value that we're missing is x. So we need to, in order to find out what x is, we need to plug it in, these y and z values, into an equation that has x. I'm just going to use the first one. So we have x plus 2 plus negative 1 equals 2. So really we have x plus 2 minus 1 equals 2. So x plus 1 equals 2. Subtract 1. And we get x equals 1. So the solution to this system of linear equations in three variables, 1, 2, negative 1. And once again, just be very careful as you're going through these. There's lots of areas for students to make mistakes. Lots of sign errors could go on. Lots of bad things. So just be really careful when you're doing these systems with three variables and three equations. Okay, so let's look at this next one here. Now this one's not as bad as the previous one. Now notice, the first one we have here, in all of the equations we have x and y and z, so we needed to eliminate them. In the second one, there's a couple equations that just have two of the variables, like, you know, this first equation here has all of them. The second equation just has two of them. The third equation has two of them. And recall, like, the whole idea was we wanted to work it down into this situation like we have here, where we have two variables and two unknowns. So with this one, if we just select the second or third one to pull off to the side, we already have one equation that only has two variables, so I'm going to pull the second one aside, say negative 2x plus y equals 3. So now what I need to do is this. I need to use the other two equations to eliminate the variable that's missing. Now notice, our equation over here just has x's and y's, which means we need to use the first and third equations. We've taken this one away, so we're not using it anymore. So we need to use the first equation and the third equation to get rid of the z's. Well, good news, we have a negative z and a positive z, so all we have to do is add those together. So right here we have x plus y plus z equals 57, so that's the first equation. Then we have x minus z equals 6. That's the second. And we could put 0y in here, but it's not necessary. So if we add these up, x plus x is 2x. Y plus nothing is y. Our z's cancel out. And 57 and 6 is 63. So now we can pull this over to the side. We have 2x plus y equals 63. And what we've done is we've taken the system that has three variables and three equations and turned it into something that has two variables and two equations, and notice we have the same variables. Both of these equations over here have x and y. So we should know how to solve this type of system over here. I'm going to use elimination because we have the negative 2y and the positive 2y. It's screaming kind of elimination. So adding these together, negative 2x plus 2x is nothing. Those cancel out. Y and y is 2y. And then 3 and 63 is 66. Divide by 2. And we get y equals 33. Okay. So, once again, the solutions to these are going to be ordered triples. So we know it's going to be some sort of like x, y, z combination. We know what our y is here, so we have 33. Now, we have these equations right here. Because we have y, we can solve for x by plugging this back in. So I'm just going to plug it into the second equation here. We have 2x plus 33 equals 63. So I just plug that back into the y. Subtract 33 from both sides. Cancellation here, so we get 2x equals 30. Divide by 2, x equals 15. Alright, so now we have two of these. We have 15 and 33. Now we have to solve for z. So in order to solve for z, we need to look back at these original equations, these ones right here, and we need to use one of the equations that has z in it to solve for z. We can't solve for z in an equation that doesn't have z. So I'm going to use the third one because it's the easiest. So I'm just going to be plugging our x in for x. There's nowhere to plug the y in, but that's okay. So we have 15 minus z equals 6. So come down here with this. So our 15 minus z equals 6. Subtract 15. Cancellation here, so our negative z carries down. 6 minus 15 is going to be negative 9. And finally, if we divide here by negative 1, we get z equals 9. So the solution to that system is 15, 33, 9. And on these, just like the ones we had before, whoa, get out of there. 9, there we go. And just like we had on the ones before, you can plug these numbers back in to make sure that your system, that is the solution to your system, just like the ones we had before. So hopefully that made sense. I know these are challenging and confusing, and challenging because there's just a lot of areas where a student can make mistakes, but keep plugging away, you'll get them. See you on the next one.